7.1 Graph exponential growth functions. We're going to be graphing today using a lot of those same shift ideas that we saw in the square root and cube root graphs. And exponential growth functions look something like this. They get real big, real fast on one side, and they get flat on the other side. This line where they get flat and get close to is called an asymptote. That's a word you'll have to know. On these parent functions, the asymptotes are always at right on the x-axis. So the equation of the asymptote would be y equals 0. Domain of every single exponential function is all real numbers. The range can vary, but on the parent functions, we see that we're looking at values of y bigger than 0. And since we don't ever actually touch 0, we don't say greater than or equal to, we just say greater than. Before we get into what a graph looks like, let's make up our own example. I'll call it example 1A, which should be in your notes. Go ahead and pause the video after I write these up. In your head, I want you to evaluate all three of these. Hopefully you remember from Algebra 1 and in this class that anything to the 0 power is always 1. Anything to the first power is itself. Anything to the second power means that something times itself. We could keep going on. 2 to the third would be 2 times 2 times 2, and so on. These are skills you'll need for the next example. So our first example for graphing exponential functions is y equals 2 to the x. Notice this does not have a shift. Shift will look something like what we saw in chapter 6. If this were our original problem, our shift would be minus 3, minus 2, just like we expect from chapter 6. Same kind of idea. But this first problem has no shift. So if I told you to write down the parent function is the same thing as the original function. Then we get to make a table. The easiest number to plug into these exponential functions is 0, 1, and 2. So that's the numbers we'll plug in. From the previous slide, we see that the answers for those three are as follows. And from that picture of an exponential graph, remember we have an asymptote at y equals 0. Next, we would apply the shift, but there isn't one. So we just immediately go straight to the graph. First thing you should always graph on these so you don't forget is your asymptote. In this case, it's right on the x-axis at y equals 0. Then we plot our points. We need to make it all the way up to 4 and all the way over to 2. So I see 0, 1, 1, 2, 2, 4. I draw the line and I get close to that asymptote and never touch it. The other side gets real steep. As always on exponential functions, my domain is all real numbers. My range is everything above the asymptote. Sometimes this graph flips over and we'll say everything below the asymptote. But right now we can see pretty clearly that we want all the y values bigger than 0, but not including 0. We don't include 0 because we never touch the asymptote. End of problem. Before we look at example 2, let's look at example 2a, which should also be in your notes. First thing I want you to do for this example is evaluate the following. 1/2 times 0, 1/2 times 1, and 1/2 times 16. Hopefully you realize anything times 0 is going to be 0. Anything times 1 is going to be itself. And for the 1/2 times 16, you should be putting the 16 over 1, cross-canceling. You get 8 over 1, or just 8. That's a skill you're going to need for example 2. There's another skill you'll need for example 2. Let's try to evaluate the following. Go ahead and pause the video and try all 3 of these yourself before I just tell you what to do. You should notice anything to the 0 is 1. Anything to the 0 is 1. But that negative in front makes it negative 1. Anything to the first power is itself, but the negative on the outside makes the whole thing negative. And anything squared, even when we square a fraction, we're just going to get the 5 squared over the 2 squared. Negative on the outside. One more thing I want you to do for these last 2. Figure out what those are as a decimal, either in your head or with a calculator. You need to be able to get decimal answers for these. It's a skill you'll need for the next example. You should be able to come up with your negative 2.5 and your negative 6.25. All of these skills will be used in the next example. If you need help with them, come back to this piece of it. So we're graphing 2 more functions. Neither of these have a shift. A shift would look like something like this, remember. So both of these are parent functions. So we can start with our table. And as before, the easy numbers to plug in are 0, 1, and 2. And to figure out what 4 to the 0 is, 1 times 1/2 is 1/2. And we need that as a decimal. 4 to the first is 4 times 1/2 is 2. Don't need to write that as a decimal because there's no fraction. Plug in 2. 4 squared is 16 times 1/2, 8. Because this is a parent function, our asymptote is at y equals 0. We now put all of that into a graph. Always start by graphing your asymptote. Then I notice my y values need to go all the way up to 8. So I should be mindful of what I'm doing. My top will be 8, so about halfway is 4, 6, 2. My x-axis, I only need to go out to 2. Now I can start plotting points. 0, 1/2, 1, 2, 2, 8. Then I draw my curve, getting close to the asymptote, but never touching. I still need to identify my domain, which is all real numbers, and my range. Even domain is all real numbers because we go forever both directions, but my y-axis is only bigger than 0, not touching 0. Done with part A. Part B is more of the same. I think it's just a little more complicated because 5 over 2 is a little scarier. So again, we plug in 0, 1, and 2. Anything to the 0 power is 1. Make it negative, negative 1. 5/2 to the first is 5/2. Make it negative. As a decimal, as we saw on the previous slide, go back if you need to. Plug in 2, you get 5 over 2 squared with a negative in front and as a decimal. Again, if you need to see where those decimals or fractions came from, go back to the previous slide. Our asymptote, because this is a parent function, we'll start seeing shifts in the next example. On all these parent functions, asymptote is y equals 0. Put in my asymptote right away. And I notice my y values this time are all down. So I should go down to about negative 8 maybe again. Negative 4, negative 2, negative 6. And I plot my points. First point is 0, negative 1. Second point is 1, negative 2.5, and 2, negative 6.25. And I draw a curve getting close to my asymptote, but never touching it. Notice this one looks upside down compared to the last one. That's because of the minus sign. We saw that with parabolas. We saw that with square roots. Any graph that has a minus in front of the whole thing really gets flipped over from what we're used to. Domain and range time. Domain goes on and on both ways forever. So we get to say domain is all real numbers. Range is not so friendly. We start at 0 and go down. So we say the range is y is less than 0. Not equal to, because we never touch the asymptote. That's it. Before we look at example 3, we're going to look at an example 3a to get you ready for it. I'm going to put up on the board 3 radical expressions, and I want you to identify the shift. I think I said I was going to put up 3. I'm only going to put up 2. Go ahead and pause the video, write these examples down, and identify the shift. This is a connection back to chapter 6, section 5, I believe. You should have gotten minus 2, minus 5, because we changed the sign here, but leave the sign alone. You should have gotten plus 7, change the sign, plus 2, leave the sign alone. This is a skill that's going to be used in the next slide when we start looking at shifting exponential graphs. So this is very similar to the exponential graphs. First, we can identify the shift. Go ahead and pause the video and try to come up with what you think the shift will be. Hopefully you thought plus 1, minus 3. That comes from changing the sign, leaving it alone. If we look at everything other than the shift, that's our parent, just like in chapter 6. We still make a graph for our parent, just like we did in chapter 6 and this chapter. Plug in our 0, 1, and 2. Anything to the 0 is 1 times 4 is 4. Anything to the 1, 2 to the first power is 2 times 4 is 8. 2 to the second power is 4 times 4, 16. And because this is a parent function, the asymptote is at y equals 0. So far, this is like what we did in the first 2 examples. Now, we apply the shift. I have not used the shift yet. Plus 1, minus 3. This is very similar to what we did in chapter 6. I'm going to add 1 to all of my x values. So I'm only looking at the x values in the chart. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. And I do the same thing for the y shift. I subtract 3. 4 minus 3, 8 minus 3, 16 minus 3. I also shift my asymptote. If I forget to do that, it's going to mess up your graph. Y was 0. I use my y shift. So I subtract 3. Pro tip, this shift is always going to match up with that number. Always. The asymptote and the shift are always the same. Then we get to graph. Looking at my numbers this time, it looks like I need to go all the way up to 13. So maybe this is 5, or maybe 3, 6, 9, 12, 13. And then my x's need to go out to 2, like they've been doing the whole time. I need to put my asymptote in right away. It's at negative 3. I say right away because I don't want you to forget. If you leave off this asymptote, your graph is wrong. Then we can plot our points. 1, 1, 2, 5, go a little further, 3, 13. Then we draw our line and get close to our asymptote. Notice I'm not getting close to my x-axis, I'm getting close to my asymptote. As always, my domain is the easy one on these, using all the x values, so I get to say all real numbers. My range, on the other hand, I'm starting at -3 and going up. I'm not including -3, so I say y is greater than -3, not greater than or equal to. At this point, you need to pause the video and try all 3 of these on your own. Number 3 is the most important because it has the shift. And don't forget, f of x is really, for all intents and purposes, the same thing as y. Good luck. That's the end of this video.